Hi everybody, my name is Sonal Kapoor, and today we're going to be looking at the most important part of Chapter 5, which is a special segment chart. Our first special segment is a perpendicular bisector. The perpendicular bisector theorem states if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment. So let's come down and look at an example. So if CD is the perpendicular bisector of AB, according to the perpendicular bisector theorem, then AC would equal BC. So let's come back up and look at the point of concurrency. The point of concurrency for a perpendicular bisector would be a circumcenter. The perpendicular bisectors of a triangle intersect at a point called the circumcenter that is equidistant from the vertices of a triangle. So let's look at an example of that. So P is the circumcenter of triangle ABC, and if that is true, according to the circumcenter theorem, then PB would equal PA, which should equal PC. Our second special segment is an angle bisector. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So, in this example, BF would be the perpendicular bisector of DBE, and if BF bisects DBE, then FD is perpendicular to BD, and FE is perpendicular to BE, then DF would equal FE. So the point of concurrency for an angle bisector is an incenter. The angle bisectors of a triangle intersect at a point called the incenter that is equidistant from each side of the triangle. So let's look at an example. P is the incenter of triangle ABC, and if that is true, then according to the incenter theorem, PD should equal PE, which should equal PF. Our third special segment is a median. A median now does not have a segment property, but let's come down and look at an example anyway. So CD in this example would be the median of ABC. A median of a triangle is a segment with endpoints being a vertex of a triangle and the midpoint of the opposite side. The point of concurrency for a median is a centroid. The medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So it pretty much just divides into 2/3. Divides like a segment into 2/3. So this is an example of a centroid. P is the centroid of ABC. And if P is the centroid of triangle ABC, then AP should equal 2/3 of AK. BP should equal 2/3 of the whole segment BL. And CP should equal 2/3 of the whole segment CJ. Our last special segment is an altitude. Just like a median, an altitude does not have a segment property. But let's look at an example. So BD is the altitude of triangle ABC, And an altitude of a triangle is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing that side. The point of concurrency for an altitude is an orthocenter, and that does not have a concurrency property. This is an example of an orthocenter. So P is the orthocenter of ABC, and the lines containing altitudes AF, CD, and BG intersect at orthocenter P, and that is the orthocenter of triangle ABC. Thank you so much for watching. I hope you enjoyed.
Now we're going to find the orthocenter, which is the point of concurrency for altitudes. An altitude goes from one point of a triangle to the opposite line where they are perpendicular. To find the orthocenter, you have to set at least two altitudes equal to each other. To find the altitudes, you have to find the equations of the lines. The slopes of perpendicular lines are negative reciprocals, so the slope of GH and its altitude are 2 and negative 1/2. The slopes of FH and its altitude are negative 2 and 1/2. After simplifying, the equations of these lines are y equals negative 1/2 x plus 3 and y equals 1/2 x plus 2. Solve for the system of equations to find the orthocenter. First, you add the equations to eliminate the x. This gives you 5/2 for y. Plug in 5/2 for y into either equation to find x. The coordinates for are 1 and 5/2.
Hi, my name is Susie Kim, and I'm going to go over indirect algebraic proof from Chapter 5. This is our free choice, but this concept can be a little confusing, so after this podcast, I hope you will have a better understanding. So this is a general guideline that you should follow. First, identify the conclusion or the proof. Second, assume the opposite of the proof. Third, follow this line of reasoning until you reach a contradiction in some known fact, such as the given, a definition, a postulate, or a theorem. And lastly, write your closing sentence. This leads to contradiction in blank, therefore state the original proof. Also, note that indirect proofs are paragraph proofs. The only difference between them and a two-column is that the chart separating the statements and reasons is replaced by the word because, separating the statement and the reasons. Here is an example that we are going to go over. First, the given is negative 3x plus 4 is greater than 16. Now we have to prove that x is less than negative 4. So this is how it goes. First, we have to assume that x is greater than negative 4 or x equals to negative 4 is true. Make a table with several different possibilities assuming that x is greater than negative 4 or x equals to negative 4. So here is the chart. First, let's assume that x is negative 4, and if we plug that into the equation negative 3x plus 4, the answer would be 16. Next, let's assume that x is negative 3. Negative 3 times negative 3 plus 4 would be 13. And if negative 2 is x, the answer would be 10. And if x is negative 1, then the answer would be 7. And lastly, if x is 0, the answer would be 4. When x is greater than negative 4, it means that negative 3x plus 4 is less than 16. And when x is equals to negative 4, it means that negative 3x plus 4 equals to 16. In both cases, the assumption leads to the contradiction of a given information that negative 3x is greater than 16. Therefore, the assumption that x is greater or equal to negative 4 must be false. So the original conclusion that x is less than negative 4 must be true. This be the end of this podcast, and I hope you enjoyed. Thank you.